right, hi, this is Mr. G with part two to potential energy and magnetic force. Our activity is to predict potential energy based on magnetic force. We want to be able to predict what will happen to potential energy based on the direction of magnetic force. Our question is, how can we tell what will happen to the potential energy? Potential energy, remember, is the energy that is stored in an object or system. When I go to my simulation, I want you to observe what happens. When I have two magnets that are very strong placed together with similar poles, they are going to repel away from each other. When I analyze what happened, I want you to look over here at the potential energy, which is in purple, and observe what happens. What did you notice or observe? That's right. As the magnets got further away from each other, the potential energy decreased. As the magnets got further away from each other, the potential energy decreased. If I go back, though, and I build two similar magnets, at first when I hit run, when they're very close together, the potential energy is 6,505 joules. But when I build them and I move them further away, at the very beginning, the potential energy is 7,160. So as I move the magnets further apart, what happened to the potential energy? Yeah, how interesting. In this case, when the magnets got further away, the potential energy increased instead of decreasing. So, how am I supposed to tell what will happen to the potential energy? The key concept, this is how you predict. When we move an object against the magnetic force, its potential energy increases. The key here, when we move an object against the magnetic force, its potential energy increases. Magnetic field lines can show you how the magnets are going to interact. Unlike poles, north and south, the magnets are going to attract to one another. With unlike or similar poles, the magnets are going to repel from one another. So we have in a magnetic field lines between unlike poles, the magnetic force is going to draw the magnets together to the left. But what if we move the magnet against the magnetic force? If we move it all the way over there, we've now moved the magnet against the magnetic force, so potential energy increases. If we have a magnet with similar poles, and we have the magnetic force is going to repel, it's going to push the other magnet away. But if we move the magnet with the magnetic force and move it over there, the potential energy will decrease because we've moved it with the magnetic force. Again, when we move an object against the magnetic force, its potential energy increases. So here I have two magnets. They're repelling away from each other, so the magnetic force is to the right. They're pushing away from each other. I'm moving the magnet against the magnetic force when I bring it in closer. So as I bring it closer to the other magnet, the potential energy increases. The key concept: when we move an object against the magnetic force, its potential energy increases. When attracting magnets, opposite poles get further apart, potential energy increases. When repelling magnets, similar poles get closer together, the potential energy increases. Let's do some practice questions. Abdul moves a magnetic toy train away from the magnet that cannot move. What happens to the potential energy in the system of magnets during the movement? Look, these are like poles or opposite poles. So the magnetic force will want to draw the train back to the magnet. But because we're pulling it further away, we're moving the magnet against the magnetic force. So the potential energy increases. Abdul moves a magnetic toy train away from a magnet that cannot move. What happens to the potential energy in the system of magnets during the movement? We have a magnetic force. These are similar poles. So these trains are repelling away from each other. So the magnetic force is pushing them away. We're moving the magnet with a magnetic force. So we're moving this train car away from the magnet. So potential energy will decrease because we've moved it with the magnetic force instead of against. In a computer simulation, Jeffrey moves a magnet toward the other magnet that cannot move. What happens to the potential energy in the system of magnets? We have similar poles. The magnetic force is trying to repel them away, but we're moving the magnet closer against the magnetic force, so potential energy will increase. I hope this helps you understand and gets ready for your quiz. Have a good day.